Okay, guys, so today we're going to move on to power series representations. So we kind of started doing that already, but I want to kind of do a warm up to make sure everybody understood the last section. The last section is very difficult. The first half of last section was about trying to, determine the interval of convergence, find out when the power series with an infinite amount of terms would be a good representative, or approaching an infinite amount of terms would be a good representative of the function. And then at the end of 11.8, or the most recent section, you then had to go and try to build your own power series from scratch, okay? So we're gonna kind of do a similar thing, but we have that same idea in our heads. We're gonna use that same concept of 1 over 1 minus f of x, right? That's what we're looking for. So if we can build that, then we know that we have a power series x to the n, okay? So what we're gonna do is we're gonna start with this power series 2x squared over 5 minus x, and we need to somehow get this to look like this, right? That's our job, okay? And again, not everything can do this, but the ones we're working with right now, this is what we're working with, okay? Or this is what we're gonna try to accomplish. So first thing I notice is that 2x squared can't be there. So I'm gonna say that we have 2x squared times 1 over 5 minus x, okay? So that seems like a pretty quick fix, okay? But then I notice that I'm supposed to have a 1 right there, and I have a 5 instead. So that means I have to pull a 5 out. So this is going to be 2x squared over 5 times 1 over 1 minus x over 5, okay? So hopefully you guys see that this is still correct. If I wanted to, I could distribute this 5 back into there, and that would be 5 minus x, which is the same as this. So I haven't done anything wrong. I've rewritten the problem. Remember, that's what we're trying to do. We're trying to transform things or change the way they appear into something else, so then we can do a nice substitution. So now we see that this, we see that this would be 2x squared over x to the 5th times over 5 times the summation of n equals 0 to infinity of x over 5. Let me close my window real quick. Sorry about that, you guys. Okay, so 2x squared over 5 times x to the 5th to the n, okay? So now let's see. This is really 2x squared over 5 is equal, times the series n equals 0. Let me scroll this up a little bit, to infinity of x to the n over 5 to the n, okay? Now in our course, we're not going to be allowed to leave an x squared out there. You'll have to mess with the homework. Some problems might be more picky than others. You'll have to see what they'll allow you, but I definitely do not want you to keep a variable or an n outside of your summation, outside of your series notation. So we're going to bring that x squared in. Keep doing that. We're going to bring that x squared in, and that will become x to the n plus 2 over 5 to the n. Right, and now all I did was I multiplied x squared into the summation. Remember, all the summation is addition or subtraction, right? So it's technically saying this term plus this term plus this term plus this term. Well, if I multiply all of that by x squared, won't that just raise the power of every term by 2? So that's what I did, is I just said, well, let's just plug this in, right? And now I have x to the n plus 2, because this power, when you have same bases, you add the power, right? So this is technically a correct answer. So I would say that this is a correct answer. This is one version of a correct answer, okay? Or you could keep going and you could rewrite this as n equals 0 to the infinity of 2x to the n plus 2 all over 5 to the n plus 1. Now, you know what? I'd probably leave this 2 outside. I still wouldn't even bring that 2 in there personally. It still would be correct to do it as well. But this is another version of the answer, okay? That is also a correct answer. And let's look. Wouldn't this just be 2 times the sum? Now, if I plug 0 in, I get, for n, I get x squared over, what, 5, plus plug 1 in, I get x cubed over, what, 25, plus x to the 4th over, so if I plug 2 in, right, this is n equals 0, this is n equals 1, this is n equals 2, so on and so on and so on. If I plug 2 in, I get x to the 4th over 5 cubed, which would be 125, and I could just play this game all day. So if I wanted, I could even write this a different way. I could even write it like this. I could write it as 2 times the summation, and I could start the summation at 1 if I wanted, instead of at 0. So notice here, I'm changing the summation starting point, the index, this is called. So I'm changing that starting point for it, but I still need to create the same terms. I cannot change the series. So I can change it to 117 if I wanted. I can change it to anything I want as long as I account for it in the series. So that's kind of the beauty and the curse of a series, is it could be rewritten any way you really want, but you got to make sure that you match your index to the same series. It cannot change. Okay, so this would then become x to the n plus 1 all over 5 to the n. Now, if you don't believe me, let's write this series. So 2 times the series. Now let's start off. Remember, now we're starting at 1. So let's plug 1 in. Wouldn't this be x squared over 5? Right, to the 1, 5 to the 1. Plus, this would be x, now plug a 2 in, this would be x squared. Plug a 2 in there, this would be 25. Plus, plug a 3 in, I'm sorry, 0, 1, 2, now let's plug a 3 in there. This would be x to the 4th over, now this would be 125. Right, so look, this is n equals 1, n equals 2, n equals 3. So it still took 3 terms to rewrite the same series, just like above. Here's 3 terms, here's 3 terms, okay? They're the same series, I haven't changed it at all, but I changed the index. So look here, the index used to be at 0, now it's at 1. If I wrote this guy out, I would get the same exact series. So all 3 of these, this series is the correct answer, this series is the correct answer, and this series is, oops, sorry, not that part. And this series is the correct answer. Okay, in general, I would like you to start your series at 0, but you have to read what the homework asks, how they want your index. And in general, I would also like you to always take your x's and your n's and bring them inside the summation notation. Okay, inside sigma notation. All right, so that's just a problem. I just wanted to kind of show you guys that series are really easy to mess with, and you can always double check and make sure you're right just by writing out some terms. If you write out 4 or 5 terms and it's the same, then you probably have the same series. Okay, so now let's start 11.9. So this will be power series representation. Okay, so we have a power series representation. So basically in the last section right here in this warm-up, we saw that we could take this function, 2x squared times 5, and multiply it by this series, and we could build that series. You guys understand what we just said, is we said that now this series is represented by 2 summation n equals 0 to infinity of x to the n plus 2 all over 5 to the n plus 1. We just said that these two things are now the same, right? They can represent each other given an infinite amount of terms, all right? So we come over here, but we did not find the, we did not find the interval of convergence. We'll start to do that, or at least the radius of convergence. We'll start to do that, where we say, okay, this is a good representative, but is it a good representative everywhere? Okay, so that's what we'll start to kind of graduate to as we do these more difficult problems. All right, so let's start off with a good example. So let's say we say find. And by the way, what I'm going to show you is how I was taught to do it and how I would like you to do it. If you go online and you Google it, you might find a different way to do it. Or if you do the way the book says to, They might do it a different way than me as well. This is the way I would like you to do it, okay? So it says find the power series. And again, you guys should start noticing it's harder to find the power series than it is to find the interval of convergence in general. Or you have to know a whole lot about power series in order to just look at it and know. Okay, oops. So I want to find the power series of 1 over 1 over 1 minus 3x squared by differentiating. The power series. You know what? Yeah, let's go ahead. I'll write this out as kind of a hint. The power series, 1 over 1 minus 3x. Okay, so I want you guys to kind of see how this is going to work. All right. So first problem is you have squared. So technically squared means 1 over 1 minus 3x times 1 over 1 minus 3x. So unfortunately, both of these would be series. And then I haven't really taught you guys how to multiply series. There is a way to multiply series as well, but it's really not worth it for me right now to try to teach you all of that in the short amount of time we have to finish 11.9 and 11.10. So we're going to kind of just rely on differentiation is going to help us with this. Okay. By the way, that's an alternate method of doing it. I have seen people do it that way as well. So what we're going to do is we're going to focus on this guy. Okay. So we're going to focus on 1 over 1 minus 3x, and we're going to build a power series for that. So we're going to say the power series for 1 over 1 minus 3x would be, let's see here, that would be summation of 3x to the n equals 0 to infinity. And this one was really nice, right? Because it was already in our perfect form. That's exactly how we want it. We want it written like that. So this is actually the summation of n equals 0. And I would like you guys in general to do this, 3 to the n, x to the n. Clean that n up, use it up, distribute it to everything inside so you get this series kind of how you're comfortable looking at it. It'll help you guys when you go to do, find the radius of convergence. It really helps to have it set up like this, okay? So we have that. So now I can say that 1 over 1 minus 3x is equal to the summation n equals 0, 3 to the n, x to the n, somewhere, right? We know that it's going to be a good representative somewhere, we think. All right, so what I'm going to do is I'm now going to take the derivative of both sides. I'm going to ddx both sides. Okay. So now this is going to lead me to, well, the derivative of this, isn't this really 1 minus 3x to the negative 1 power, right? So when I take the derivative of this, I'm going to get over here, I'm going to take the power, put it in front, so that's negative 1, rewrite the inside, reduce the power by 1, and then multiply by the derivative of the inside, use the chain rule. So that would be that. So hopefully you guys followed along. That's all I did was I did the chain rule on this guy, right? On that binomial. So then we now have, I guess it's not a binomial because it's a negative exponent, but you get the idea. The inside part is a binomial. So now we're going to differentiate this. Now remember, this is ddx. So ddx kind of hops past everything and it goes right after that x to the n. As far as ddx is concerned, this 3 to the n right here, this 3 to the n right here is just a constant, okay? So as far as they're concerned, we're just going to go straight past that, and we're going to focus on n equals 0 to infinity of 3 to the n. Now, what's the derivative of x to the n? Wouldn't it be n x to the n minus 1? Isn't that how we do our derivatives, right? So we would get 3 to the n times n, x to the n minus 1, right? Everybody okay with this? So that means then that, so you see here, if we clean this up, I'm going to clean this up now. That's going to become what? 3 over 1 minus 3x squared. I'm going to write that in the denominator. And that's going to be equivalent to this series. And n equals 0. to infinity of 3 to the n x to the n minus 1. So we now know this fact. We know that this is a true statement. Now, if you look back, look at this in comparison to the original problem that I wanted you to find. Okay, so I wanted that exact 1 over 1 minus 3x quantity squared to be a series. Well, I'm almost there. I'm saying that this series now, this series right here, I'm sorry, this function is worth that series. So I'm almost there. So all I have to do is I have to say, well, I guess I'll do this. Well, then I can just multiply 1/3 times both sides, and these 3's will cancel. And now I have 1 over 1 minus 3x quantity squared equals 1/3 summation n equals 0 to infinity of 3 to the n x to the n minus 1. And that would be our answer. Right now, if somebody wants to get fancy, let me show you something real quick. Now, technically, now think about this real quick. If I plug 0 in for the first term, okay, so this is something you got to pay attention to. This is a little technicality, and I don't want you to miss it on the homework or on an exam because of this. If I plug 0 in, like right all the way up here, once I've taken the derivative, right? So right here, I took the derivative, okay? So if I plug 0 in right now for n, wouldn't I get 3 to the 0 times 0? So wouldn't the first term, when you plug it in, be 0? So that's redundant. Why would you write 0 as the first term, right? If I told you, hey, how much money do you have? You don't say, oh, I have 0 plus $3. You would just say, I have $3. So what we're going to do is we're going to change our index to 1. We're going to move it up 1 bigger, okay? Because the point of plugging 0 in, if I plug 0 in, I would have got 0. But now I'm plugging 1 in, so I get to keep this term, right? It's not just going to wipe out, okay? So that's a little technicality you got to be careful of. And so all of these are now 1s, right? They used to be 0s, and now they're all 1s. So this is something that whenever you take the derivative of, this is just kind of notation you have to adjust, okay? So now, what if somebody wanted to say then, I want to put that 3 inside. So this would become the summation n equals 1 to infinity of 3 to the n minus 1 n x to the n minus 1. Do you guys see why? Because this was division by 3. So if I throw it inside, this is 3 to the n divided by 3 to the 1. So that'd be n minus 1. So all I did was clean that up. And this is the correct answer, and this is the correct answer. I'll have to take a look at your homework and see how they want it, but you should be able to write both based on whatever they say, okay? So just keep that in mind when you're building your own power series. So kind of the thing I want you guys to notice is you had to have foresight and say, what does this series kind of look like? I'm sorry, what does this function kind of look like in terms of a power series that I could quickly convert? So I focused on this guy. They won't always tell you what series to use or what function to use. You kind of have to do that yourself. You have to say, okay, that series or that function can be represented by this function, and I know how to take that function's derivative very quickly. So in general, this is kind of a strategy when you have a perfect, or when you have a squared term, like the entire denominator squared, not like just x squared, but the entire quantity squared. This is normally your go-to strategy for my class, is where you use differentiation. Again, there are other techniques, but this is the one I choose to use. You could use multiplication of series, but I don't like that as much. Okay, this is much more heavily focused on calculus. Okay, so hopefully you guys are okay with that. Now let's look at another problem. What if somebody said, I want you to find the power series power series for, and let's do the exact same thing, 1 over 1 minus 3x quantity squared, 1 over 1 minus 3x quantity squared, but let's change this to an x cubed, okay? So all you would have to do is because you know that this is really x cubed times 1 over 1 minus 3x quantity squared. Because you know this, right? I guess that would be fair to write like that. Because you know that's true, well, you already found the series for 1 over 1 minus 3x squared. You know that this is the series. What did we say? It was 3 to the n minus 1, n, x to the n minus 1, right? But I showed you guys in the previous problem that if you have an x cubed on the outside, all you have to do is multiply it inside. So this would become the series 3 to the n minus 1, n, x to the n. But now you're taking 3 and adding it to n minus 1. So this would become x to the n plus 2. So all I did was I added 3 to this power of n minus 1 because they're same bases if you multiplied it inside, right? So this came in here and added because same bases, you add powers. So this would be your answer and you're done. Now that was super easy because you already had this series. So keep that in mind. A lot of times what will happen is they'll give you this as your starting series and you have to think about it in pieces. You have to think about, well, what's kind of the base that I can take out of there and I can turn it into my 1 over 1 minus f of x, then differentiate that, then multiply by whatever they ask me to, okay? So just so you guys know, normally they don't give you the base series. You have to figure it out by yourself, okay? But I just wanted to give you a heads up on that. It's kind of a cool way to work on these problems is you start with this basic function or this basic series, power series, and you just keep manipulating it to get a little bit, or to get to the place you want to go. So it's almost like you have to know where you want to end up and also know where you came from. And then the math, the calculus is just the manipulation of your series in between, okay? And using the derivative to your advantage, all right? So I just wanted to show you guys that one. All right, so let's move on to a slightly harder problem. It says find the power series. Cannot write tonight. Series for the natural log of the absolute value of 3 minus 2x. And I want you to do it by integrating. So this time I'm not going to tell you what the series is, or I'm not going to tell you the base function we should work with. Okay, so you have to think, well, really right now, so again, you guys are going to learn much more, but right now all we have is this. We have our 1 over 1 minus f of x, right, is equal to the series, right? That's what we have. That's it. Oops. F of x to the n. That's all we got, right? We have 1 over 1 minus. Did I write that wrong up here also? I'm thinking back. I think I wrote it wrong. No, I wrote it. Yeah, I wrote it wrong right here. F of x to the n. Thank you for reminding me of that. Just kidding. All right, so a little online humor. All right, so we have find the power series for ln of 3 minus 2x, absolute value. And I want to somehow take this and get to this, right? How am I going to do that? I mean, it's kind of hard to think about it. But now you have to think, well, we want to use integration this time. So we have to think of something that when you integrate it, you would get ln of 3 minus 2x. Well, I know that. I know that if I integrate 1 over, so let's write this out first. Let's write out first that, how do I say this? 1 over 3 minus 2x is equal to a series. So I know I'm going to focus on that part, right? Oops. So I'm going to find my power series representative for that. And I need that to be 1 over 1 minus f of x, like that. So then I can do this, right? This is my goal. This is what I want to do because this is what I have to work with. I need that guy. So I'm going to have to do a little bit of quick manipulation. Let's see here. We want 1 over 1 minus, okay? So that means that we're going to have to rewrite this as 1 over, and now I'm going to factor out a 2, let's see here, 2/3 maybe? Well, I got to factor out a 3 first, and that would be 1 minus 2/3 x. Oh yeah, I guess I don't have to clean it all up at once. I was trying to do all of it. Okay, sorry about that. So if I factor 3 out, I get that. And then that means that I have 1/3 times the series. You know what, let me write it like this. So I now know that I have 1/3 times 1 over 1 minus 2/3 x, right? So I know that this is 1/3 times the series 2 over 3 x to the n, but I know that is really 1/3 times the series. Let's do n equals 0 to infinity, n equals 0 to infinity, and this is 2 to the n, x to the n over 3 to the n. Now, if I want, I can put this 3 inside here. That 1/3 can go inside, so this will be 3 to the n plus 1. All right, I can do that if I want. Okay, everybody okay with that so far? So that's what I did. And a lot of times when you're working like this, you want everything inside the summation. You don't want like leftovers and stragglers hanging around outside of the series or the summation, the sigma notation, because it might come back to bite you because you might forget it or not know how to deal with it. Again, if you're really comfortable with it, you'll probably figure it out regardless, but I just wanted to give you a heads up on that. So now we're here. So we have this. So let me bring this over here. Oops. Let me bring this over here. So I now have that 1 over 3 minus 2x is equal to this series. Right? Because that's what I just showed. I have just shown that this is equal to this, right? These two are the same, right? So now I need to get to what they asked me for. They asked me for the ln of 3 minus 2x. Well, I know that if I integrate this guy right here, if I integrate this guy and I integrate this guy, then I know that I will get ln, right, of the absolute value of 3 minus 2x, right? Now there is a catch, right? You have to use a little, sometimes I refer to it as a baby u sub because you're only off by a constant, 3 minus 2x. So it's like a very easy, quick u sub, but a lot of people forget it. So I guess I shouldn't call it that because it gets forgotten so often. And then you divide both sides by -2. So you actually have -1/2. I'll put it in red outside. So I have -1/2 ln of 3 minus 2x, okay? Don't forget plus c, right? And that equals, now the integral, just like with the derivative, it's going to go right after the x. It doesn't actually care about the 2 to the n or the 3 to the n plus 1. So I can put it inside the summation, and this would be 2 to the n over 3 to the n plus 1 times the integral of x to the n, right? So I'm really focusing on this x to the n. Well, isn't the integral of that x to the n plus 1 divided by n plus 1? Remember, x to the n, that literally the formula for that you first memorized in Calculus 1 for integrating x to the n, the general power rule, is literally x to the n plus 1 over n plus 1. So we're just basically doing the power rule, so we're done. So now our job is to solve for ln of 3 minus 2x. Now the problem is we have this c floating around, right? So we have to pick something, okay? We want to pick something that will help us clean up this side over here really well. We really want to clean that side up really, really quick. So we're going to have to pick a value for x because remember, n is not the variable like you think. N has to change in a certain format. X can be anything, right? N has to be, 1, 0, 1, 2, 3. It can't be decimals. It can't be any of that. However, x is a variable. So we're going to focus in on x. So we're going to say let, and this is what you do if you have this plus c. Let x equal 0. And again, it could be any number, but you want to pick a number that cleans up the right side. If I take 0 and I plug it right in there, you guys see that right there? If I take 0 and plug it in here for x, you guys see that I'm going to get 0 times everything. So the whole right side is going to become 0. So I'm going to be left with -1/2 ln, the absolute value of 3 minus 2x plus c equals 0. The whole right side wipes out and becomes 0 if x is 0, right? Okay, so now I can solve for C. So I can say C equals 1/2. Oops, forgot. This is actually 0 also. So this would just be ln of 3, but you don't need absolute values anymore because the ln of 3 is just the ln of 3. So this would be the ln of 3 plus C equals 0. So then C equals the ln of 3 times 1/2. So we have now found our C. So that's our C, okay? And now let's write out our function, or I'm sorry, our power series. So we now have negative 1/2 ln of the absolute value of 3 minus 2x plus our C. So that would be plus ln of 3 over 2, right? Equals the series, n equals 0 to infinity, of 2 to the n over 3 to the n plus 1, x to the n plus 1 over n plus 1, right? A little complicated, but that's what it is, right? There's nothing we can do about that. Now our job is to solve for ln of 3 minus 2x. We got to get this alone. Once again, that's what we're trying to isolate, because way up here, this was the original goal. Find the power series for that. So that's what we're working on right now, okay? So we're going to isolate that. We're going to have negative 1/2 ln of the absolute value of 3 minus 2x equals negative ln of 3 over 2 plus the summation of 2 to the n over 3 to the n. Oops. I guess I could write it like this, x to the n plus 1 times n plus 1. I could do that as well. So that's still fine. Now we have to multiply everything by -2 because we got to make the 1/2 go away. So this will become ln of the absolute value of 3 minus 2x equals, multiply everything by -2. Let's see what happens. So this will become, it's kind of wrong how I wrote that. Let me write this a little better. So that will become I guess ln of 3 minus 2 times the summation of 2 to the n. And you could put the 2 inside, 2 to the n plus 1 if you wanted, x to the n plus 1 all over 3 to the n plus 1 times n plus 1. Okay, and that would be our answer. And again, how do I know I'm right? Because I isolated the ln of 3 minus 2x, and I started with this foundation. Look way up here. This is what I started with. This is where everything came from, right? This original power series, okay? So I don't want to call it a parent power series, but it almost feels like that's where all this came from for this particular one, okay? That's going to do it for this video, guys. I'm splitting this section into 2 shorter videos instead of one super long one. So I'm going to send this out to you guys, and you can go ahead and take a look at this. And then the previous video was a little bit longer, about 45 minutes, I think. All right, that's going to do it for this. I'm going to end the video now, and hopefully you guys were able to work on this. Again, these are definitely problems you need to ask me for help on. These are kind of strange, okay? All right, you guys take care. See you in the next meeting.